Here I am skipping around chapter 8 again. I'm skipping ahead to 8.4, the determinant of a matrix. The determinant of a square matrix is a descriptive number with applications. It kind of feels like the dot product to me. All alone, the dot product was just a number, but then it's used in all kinds of formulas and stuff, right? So we're going to learn how to calculate a determinant today. 2 by 2 determinant is probably the easiest one to do. If you have entries of A, B, C, and D, the determinant is the A times the D minus the B times the C. And I guess that's something we just have to memorize. I like to look at it like this: the A times the D minus the B times the C. It almost feels like a crisscross sort of thing. So if we were to do the determinant of this example, I would do the 4 times the 1 minus the 6 times the negative 2. I've got 4 minus negative 12. The determinant of this first matrix is 16. What that tells us, we have absolutely no idea yet. Sometimes they're going to use absolute value bars, it looks like. So instead of using those little boxes that we're used to around a matrix, they're going to just have straight up and down bars. That indicates that they're talking about the determinant. So watch for that. If you just see those vertical bars that look like absolute values, they mean that they're talking about determinant. We're going to take 5 times negative 2 minus 10 times negative 1. That's negative 10 minus negative 10. That's 0. I wonder if that's special. We knew that gave us orthogonal vectors back in the day, but what does a determinant of 0 give us? Probably something cool. What if we had a 3 by 3 matrix? How could we find a determinant then? Because we can't just go this times this minus this times this. So there's a few different ways that we can figure it out. We're going to study 3 different ways that we can get this. The first one is called using minors, or minors and cofactors. Here's how it goes. I've got one little example up here. It goes, we take this value A times this little minor determinant. And then we go minus, and we take this entry B times, and then, like it shows right here, we kind of ignore everything that's lined up with B, and we use the D, F, G, I as the minor that goes with the B. So D, F, G, I is the minor that goes with the B. And then we move over to the C and take the sort of diagonal minor determinant away from that one, and we're going to add that one on. Did you notice this was positive, this was negative, this was positive? Well, there's kind of an order for that. There's a sign pattern for the cofactors. You can do it for any size matrix, but if we're sticking to our 3 by 3s, that just means that you could go to any row. Let's say you want to use the middle row. That's fine too. You would just have to use the negative D times its BCHI plus the positive E times its ACGI minus the F times its ABGH. We might need to see an example to make sense of this. So here's my example. I just made a big string of numbers. So we are going to find the determinant. Again, it's not as simple as this times this minus this times this because there's too many numbers. So we're going to just use the top row. And so we know that this is going to be a positive 1 times the determinant of 5, 6, 8, 9. We go over to the 2. Now we have to do minus on that one, right? It goes plus, minus, plus. Minus 2. And that determinant is going to be the 4, 6, 7, 9. And finally, we'll move on to the 3, which is a positive sign. So we'll go plus 3. And we'll grab the 4, 5, 7, 8. Amazing. So my determinant it's going to be 1 times this mini determinant, 5 times 9 minus 6 times 8, which they tell me is -3, minus 2 times 4 times 9 minus 6 times 7, -6, plus 3 times 4 times 8 minus 5 times 7, which is -3. Let's see what we got all together. A -3 plus a 12 minus a 9, a determinant of 0 again. I wonder if this is a special matrix for some reason. So that's just one way of finding the determinant of a 3 by 3 matrix. Here's another option that maybe you'll even like better. It's called using the diagonals. At first it seems kind of strange, but stick with me. Probably this box off to the side is more confusing than it's worth. Let's try just doing one, and then you'll see what this box is all about. So I'm going to rewrite those numbers, but then I'm going to start repeating them again. I'm going to write the 2, 3, 4. I'm going to write the -1, -2, 5 again, and that should actually be enough. Because what I'm going to actually do is I'm going to start looking at the diagonals. In fact, we're going to probably call this the diagonals method. And we're going to multiply these 3 together. And multiply these 3 together. And multiply these 3 together. And add them all up. Fun. Now, we're going to do the other 3 diagonals. Multiply these 3 together. Multiply these 3 together. Multiply these 3 together. And add them all up. And then, drum roll please, we're going to take the first slanty diagonals minus the second slanty diagonals, and the result is the determinant. What do you think of that? Where do they come up with these things? We'll have you practice each of those methods. And the third method, making our calculator do it for us. This is the one we did before. It took us a while using that method of minors, but let's see what we can do. Second matrix. Let's edit and get that one entered in to the 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go to my blank screen. If you guessed, it's going to be under second matrix, under matrix math. You are correct. And look, it's the very first option. The very first option is a determinant. The determinant of matrix A. 0. That's what we got. That's what we got. The determinant is 0. I'm guessing that's our favorite method, but we do need to know how to use our brains as well. And that's our little lesson on determinants.